Good morning, myself Pawan Kumar. So I will be taking inorganic chemistry for B.Sc third semester students. So let us start with the first unit of inorganic chemistry, D block elements. So we all know that elements, the whole periodic table have been classified into four blocks: S block, P block, D block, and F block elements. So as we know, S block is present at the left hand side of the periodic table, and P block is present at right hand side of the periodic table, and D block, which is present exactly at the middle of the periodic table, constitute of group 3 to group 12. So on this basis we can say D block elements are called as transition elements. So since the gradual change of properties from metallic to non-metallic properties. So D block elements are called as transition elements due to gradual change of properties from metallic to non-metallic properties. So we can define D block elements. So all D block elements contain partially filled d orbitals. So hence D block elements or transition metals are defined as those elements which contain partially filled d subshells either in their ground state or in their common oxidation state. There are four series of D block elements, so namely 3D, 4D, 5D and 6D series of D block elements. All these four series contain 10 elements each. So group 11 elements like copper, silver and gold have completely filled d orbitals in their atom. However, they possess partially filled d orbitals in their stable oxidation states. Hence, they are included under transition metals. So here you can see some examples of group 11. Copper, you have 10 electrons in 3D subshell and 1 electron in the 4s subshell of ground state. So excited state, that is in its ionic state, copper plus 2 is having 9 electrons in 3D subshell and 0, that is no electrons present in the 4s subshell. So similarly, group 12 elements like zinc, cadmium and mercury cannot be transition elements according to the above definition, as we have seen in the definition of D block, because they have completely filled orbitals in their atomic state as well as ionic state. So in the example you can see zinc, the outermost electronic configuration comes to be 10 electrons present in the 3D subshell and 2 electrons present in the 4s subshell, which is again a completely filled D and S subshell. So zinc in its ionic state Zn plus 2 also has 10 electrons in 3D subshell. So according to the above definition, you cannot call zinc as a transition, but still it is included in the group 12. However, the elements of group 12 are also considered as transition metals because they exhibit several properties which are similar to the properties of other transition metals. So that's why these elements are called as pseudo transition metals. So next we shall come on to we shall see some chemistry of elements of first transition series like electronic configuration, ionic radioionization energy, melting point, boiling point and so on. So let us first look at the electronic configuration of first transition series, that is 3D series. So while studying D block elements, we study period wise, not as group wise. So as we study 3D series of elements, so as we move from scandium to zinc, that is scandium to zinc belongs to a 3D series of transition elements. 3D subshell goes on successive fill. So hence general electronic configuration of 3D series comes to be, it is argon 3D subshell 1 to 10 and 4s subshell, it is 1 to 2. So let us see the electronic configuration of the 3D series of our first transition series of D block elements, that is 3D series. So first element we can see as is scandium, which is having atomic number 21. So you can see here argon. So we shall take the previous noble gas. So instead of writing a very lengthy electronic configuration, we will consider the previous noble gas to write the electronic configuration argon, which is having an atomic number 18. So remaining outer shell configuration is written as it is. So for scandium, atomic number is 21. Argon, so argon is 18. 3d1 4s2. So 18 plus 1 plus 2 it becomes 21. So next we can come to the titanium 22, vanadium 23, so chromium 24. Here there are some anomalous or peculiar electronic configuration with respect to this first transition series. So for titanium you can see D block goes on filling. So vanadium is 3d2, titanium is 3d2, vanadium 3d3, chromium, which is having atomic number 24, it should have been 3d4 and 4s2, but instead, so one electron from 4s subshell goes to the 3d subshell and it makes it 3d5 and 4s1 because, so as you know, so half filled or completely filled gives even a stable electronic configuration. To attain the stable state, you have one electron of 4s subshell jumps to the 3d subshell, making it a half filled electronic configuration, making it a stable electronic configuration. Manganese, so 25 again 3d5 and 4s2. Iron, so again goes on 3d subshell, now goes on filling. Iron having 26. The electronic configuration comes to be argon 3d6 4s2, cobalt 27, argon 3d7 4s2, nickel 28, so argon 3d8 4s2, copper again one other anomalous electronic configuration which is having atomic number 29. It should be 3d9 4s2, but instead to make it a stable electronic configuration, one electron from 4s subshell jumps to the 3d and makes it a 3d10 electronic configuration. So here in 3d series of elements we have seen two anomalous or peculiar electronic configurations. One is chromium, so where one electron from 4s jumps to the 3d subshell and make it half filled, and in case of copper, which is having atomic number 29, one electron from 4s subshell jumps to the 3d and makes it 3d10. So zinc again having electronic configuration, atomic number 30, its electronic configuration comes to be argon 3d10 and 4s2.